While CAD geometry is designed to be perfect, a certain amount of variation is inherent in any manufacturing process. In 3DCS, tolerances add that variation to the nominal CAD geometry. As individual parts are assembled, tolerances stack up and can lead to even greater variation in the overall assembly. Hence, tolerances play a vital role in the manufacturing of any product. The tolerances used in the 3DCS model can come from actual measured parts, from detailed tolerances allowed on the prints, or from what-if scenarios. Manufactured part dimensions will not always be at the maximum or minimum values specified in detailed prints. 3DCS allows the user to set the range, offset, distribution, and other parameters of the tolerance to simulate the manufacturing process as closely as possible. The exact value of the dimension is randomly generated during the simulation by a Monte Carlo random number generator according to these parameters. There are two main categories of tolerances: DCS tolerances and DCS GD&T. DCS tolerances are used for applying variation directly to points or features. DCS GD&T adds variation according to GD&T callouts in the model.